In this example, you will consider a piecewise function. A piecewise function is defined on a sequence of intervals. For the given piecewise function, there are two different functions defined on two different intervals. The first function is a linear function and is defined in the set of numbers greater than or equal to 3. The second function is a quadratic function and is defined in the set of numbers less than 3. In Part A, you are asked to evaluate the function for different x values. You need to substitute the values of x into the functions at the appropriate intervals. Since the values -1 and 0 are less than 3, you need to use the second piece, negative x minus 2 squared, such that x is less than 3. To evaluate the function at x equals -1, just substitute -1 into the given function. F of -1 equals -1 minus 2 squared equals -3 squared equals -9. In the same way, you evaluate f of 0 equals -0 minus 2 squared equals -4. To evaluate f of 3 and f of 5, substitute these values into the piece defined for x greater than or equal to 3. Hence, f of 3 equals 3 minus 4 equals -1. And similarly, f of 5 equals 5 minus 4 equals 1. For Part B, sketch both functions on their respective domains. You can see that for the linear function, the gradient is 1 and the y-intercept is -4. For the quadratic function, the vertex is 2, 0, and the y-intercept is -4. Although the quadratic function is not defined at x equals 3, it actually has the same value as the linear function at x equals 3, and therefore the two pieces can be joined together with no spaces or holes in the graph. You can clearly see from the sketch of the piecewise function that the domain and range are the set of real numbers.